Question number 5 from motion in a plane DPP. It states that there is an inclined plane of inclination 30 degrees. The horizontal velocity v0 so that the particle hits the inclined plane perpendicularly is. So let us assume this is our inclined plane. This is the point from where we are projecting the object, and let us consider a line which is parallel to the inclined plane and passing through the point of projection. Here we are throwing it horizontally with a velocity v0, and it is going to come and hit the plane perpendicularly in this direction, right? So let us assume this is our x-axis, and perpendicular to the inclined plane this is our y-axis, right? This is given as 30 degrees angle, right? So if I consider the g value here, which is acceleration due to gravity, if I consider the components along the x and y direction, this is going to be 60 degrees, this is 30 degrees here. So g cos 30 in this direction, which is g into root 3 by 2, g sin 30, which is equals to g by 2 here. And similarly, this is 30 degrees, this is 60. Similarly, this will be also equals to 30 degrees, right? So component of the velocity in this direction is going to be v0 into root 3 by 2, and perpendicular to the plane is going to be v0 upon 2, right? So along x direction we can see that when it is going to hit here, the velocity in x direction is going to be equal to 0, and initial velocity in y direction is v0 into root 3 by 2. Acceleration along the x direction is, along with sign, minus g by 2. Acceleration along y direction is minus g into root 3 by 2 along with sign. So as we are having constant accelerations here along the x direction, I am going to apply v is equals to u plus at, that is vx is equals to ux plus ax into t, to find out the time at which it is going to hit the inclined plane. Final velocity is 0. Initial velocity in x direction is v0 into root 3 upon 2. Acceleration in x direction is minus g by 2, and the time capital T to hit the inclined plane. 2 can be cancelled out here. So I am getting capital T is equals to root 3 into v0 upon g. The time of flight of the projectile is calculated now. Now let us go to y direction. This is given as h. So this is 60 degrees, which implies this distance is going to be equal to h sin 60, which is root 3 h upon 2, right? So along y direction I am just going to apply sy is equals to uy into t plus half ay into t square, right? Just substitute everything. Sy is minus root 3 into h by 2 in downward direction, right? Minus h root 3 h by 2. Uy is minus v0 by 2. Time taken is root 3 into v0 upon g plus half into ay is minus g into root 3 upon 2. T square will be is equals to 3 v0 square upon g square. This g I can cancel out here. Negative sign is common everywhere, you can just remove that. Root 3 is also common everywhere, you can cancel it out. 2 is common everywhere, you can cancel it out. So we have to just simplify this equation here to find out that v0 value. So on the left hand side we are left out with h. Right hand side, the first term is going to be v0 square upon g, and the second term is going to be 3 v0 square upon g, 2g, sorry. So this indicates that v0 square, 5 v0 square upon 2g is equals to h, which implies v0 is going to be equals to root of 2gh upon 5. So this is our final answer. Checking the options, we can see that root of 2gh upon 5 is going to be option 1. Thank you.